everyone, I am Radhika. Welcome back to DataZad. In this video, we are going to be solving another Leetcode problem, which is called as 3 sum, and it is problem number 15 in Leetcode, and it is medium problem. Now let us try to understand what the problem is about. Given an integer array nums, we are given an array of integers and we need to return all the triplets where triplet is forming nums of I, nums of j and nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k, which means none of these indexes should get repeated, and the sum of these three numbers which are selected, it should be equal to 0. So if you look at this, I'm taking the first example from here. This is the integer array that we are given. It's called nums. We need to find all three numbers, like combination of three numbers, such that their sum is equal to 0. The first combination could be -1, 0 and +1, these three numbers, and the other combination could be -1, -1 and 2. These are the only two combinations that will give us sum of 0, and where I will not be equal to j, j will not be equal to k, and k will not be equal to I, which means we can't use -1, -1 and 2. We have -1 here, but it's coming from a different index. In order to do this, what we can do is, the first technique would be just taking all of these. So we take -1 and build all the combinations with -1. So it would be -1, 0, 1, then -1, 1, 2, then -1, 2, -1, and build all of these combinations, and then try to find the sum of all of these ones, and then decide whether it is equal to 0 or not. If it is 0, then we keep it as a triplet, otherwise we ignore it. But this technique is not the most efficient way to do it. There is a better way, and let's look into what it is. I have copied the same numbers over here. Now what we can do is, first let us sort this. So our new nums would become -4, -1, -1, 0, 1 and 2. This is our sorted array. What we need is three numbers from this array such that their sum is equal to 0. So to do that, let us first take this as I. I'm going to loop through all the numbers, and to get the other two numbers, I'm going to use two pointers, left and right. So I'm going to initialize my left pointer over here and my right pointer over here. Why I'm doing this? Because if I'm taking this as I need to find the other two numbers between these two numbers. So my left should be next to I, and my right should be the last value in the array. Now if you look at it, our current sum is equal to -4 plus -1 plus 2. This is I, this is L, and this is R. So -4 -1 plus 2, which is equal to -3. Now is our sum equal to 0? It is not. Our sum is less than 0. -3 is less than 0. If it is less than 0, we need to bring our left in the forward direction. Why? Because when we are bringing into forward direction, we are increasing L. If you forget about this, if our L was equal to 0 instead of -1, then our sum would be equal to -4 plus 0 plus 2, which will be equal to -2, and -2 is greater than -3. So we are increasing our sum so that it reaches 0. So in this case, what we need to do is, we need to increase our left. So, and instead of this as left, I'm going to choose this as left. Now the problem is, our previous left and the current left, they are both equal. Because they are equal, we're going to get the same sum. So we don't need to check for these, and we can eliminate these iterations. And the next L that we need to check should be equal to this one. And currently we are still within the range, and our condition, which was I should not be equal to j, j should not be equal to k, and k should not be equal to I. Like these indexes should not overlap on one another. It still followed because our I, L and R, they are at three different places. Now let's find the sum. So sum will be equal to -4 plus 0 plus 2, which will be equal to -2. It is still less than 0, which means we still have to increase it. To increase it, we are going to move our L again over here. So if I remove this and change my L to this location, then my sum would be equal to -4 plus 1 plus 2, which is equal to -1. Still better, but not there. Still less than 0. We still need to increase our L. So if we do that, now my L would be equal to on the same location as my R is. And we are violating this condition. That is why we can't do it, and we will not have any triplet which will have -4 in it. So let's remove everything, and now I'm going to shift my I. So next I that I'm going to look for is this one. When we are looking at this I, again we check whether our current I is equal to previous I. No, it is not. Previous I was -4, this is -1. So we can loop through this. Now again I'm going to initialize my left and my right. These are my left and right. Now again I'm going to find the sum. Sum of I, L and R, which is our triplets, is -1 plus -1 plus 2, which is equal to 0. We have got our sum is equal to 0 because that's exactly what we wanted, which means we have got our first triplets. So our first triplet is -1, -1, 2. Now that we have got these triplets, we know that we have L and right. We need to update both left and right. So I'm going to increase my left position from this to this, and I'm going to decrease my right because that's what the direction of right should be. It should go in the backward direction. So this will be my right. Now again I'm going to find sum. So sum would be equal to -1 plus 0 plus 1, which will be equal to 0. Again this is a triplet that we need because sum is equal to 0. So now again I'm going to save this. So this will be equal to -1, 0, plus 1. Now we will again shift our left and right. If we shift our left and right, they will go past it. We don't have to do that because we have already checked those combinations, 1 and 0 or 0 and 1. We can't do that. Our left should always be less than right. When it is not, we stop the loop. So now we choose a different I. So now we move our I to here. Now, is our current I equal to previous I? Yes, it is, which means it's a duplicate and we need to skip it because it is already mentioned in the challenge that we don't need any duplicates. So let's move our I again. So we move our I over here. Now again, I'm going to initialize my left and right. So my left would be equal to here and my right is here. Now we're going to find the sum. So sum would be equal to 0 plus 1 plus 2, which is equal to 3. Is our sum equal to 0? No, it is not. This is not a triplet and we need to move. Currently, our sum is greater than 0, which means we have to reduce the sum. To reduce it, we need to move our right in the left direction. When we move this, our left and right will both be pointing to the same location. This cannot happen. So because of this condition, so there is no triplet found here. And now we are again going to increase our I. Now as soon as you see that I is a positive number, it's greater than 0, it means that we will not have any negative numbers left because this is a sorted array and the num of I will always be increasing. And because it will always be increasing, it doesn't have a negative number, so can never be 0, which means we can stop over there. This is the exact same logic that I'm going to use in the code as well. Let's do that quickly. First, we will start by sorting the array. So for sorting, we will do nums.sort so that the array gets sorted in its own place. Now we are going to define an array which will be storing our final results. So all the triplets will be stored in this final array. I'm going to loop through all the elements of the array. So for I in range length of nums, we first check if the nums of I is greater than 0. Why greater than 0? Because if it is greater than 0, then we don't have any number to negate it, so that sum of the numbers will be equal to 0, because all the numbers, they are positive numbers and sum of positive numbers cannot be equal to 0. So that's when we'll do a break, which means we cannot find any triplets from there on. Otherwise, if I is greater than 0 and nums of I is equal to nums of I minus 1, what we are checking here is when we are within the array, but the current element that we are checking, which is nums of I, if it is equal to the previous element that we have checked, then we will just continue because it is a duplicate and we have already found all the combination of triplets from there. Then we are going to define the left and right. So left would be equal to I plus 1. We initialize left with the next element from I, that's why it's I plus 1. And right will be equal to length of the nums array minus 1. So this will be the last element of the array. Now, while our left is less than right, because we always want to be within the array, our left pointer should always be less than the right pointer. Then let's find the sum of the numbers, sum of nums of I, nums of left and nums of right. So that will be equal to nums of I plus nums of left, because these are the triplets that we have in hand right now. We don't know if these will be ending up in the final answer or not, but at least find the sum of it. If the sum is less than 0, then this means that we have to shift our left to one position ahead so that we get a bigger number and our sum increases. So we'll do left plus equal to 1. This is shorthand notation of writing left is equal to left plus 1. And now I will write elif. Otherwise, if the sum is greater than 0, which means we have to shift our right position. This is right is equal to right minus 1. Otherwise, we have found our triplet, because then the sum would be equal to 0. And when we have found our triplet, we can do final dot append. And then in array, we'll write nums of I, nums of left, and nums of right. Order of this doesn't matter, it is already mentioned in the challenge, so we can write anything. And now here we will do, now we need to check for the coming left and right. If they are equal, then we have to ignore them. So that's why I'm checking if left is still less than right, and our nums of left, like the current left that we have, if it is equal to nums of left plus 1, the next left after it, then we'll just do left is equal to left plus 1. So left plus equal to 1. Similarly, we'll have to do this for right as well. So while left is less than right, because we are running this loop, so we'll again have to check left is less than right, and nums of right is equal to nums of, we have to do right minus 1, because right moves in the backward direction. If this is the case, then again we do right minus equal to 1. Right is equal to right minus 1. And then we'll have to update our left and right as well, because by these we were just ignoring the duplicates for left and right. Now we update our left to be equal to left plus 1 and right to be right minus 1. And once all of this loop is run, then we just return our final answer, so which is the final array. So this is the final solution. I hope you have understood the logic behind this. If you have any questions, then please drop them in the comments below. Thank you for watching. I'll see you in my next one.